Hi, this tutorial covers the mean. Let's start with the definition of the mean. So the mean is the average value of a data set. Okay, the mean can be used to describe the center. Remember, when describing the distribution, we want to describe the center, the spread, the shape, and then any unusual features. So this is one way of measuring the center. So sometimes we call this the mean a measure of center or a measure of central tendency of a data distribution. So the population mean is often unknown and is denoted with the Greek letter mu. Sometimes I'll draw mu like that. Okay, oftentimes mu will not be able to be calculated because it's going to be rare that you have every element of a population. So generally this is just used to represent the mean. This usually we don't assign a number. Okay. Now, whereas the mean of a sample can generally be calculated and is denoted with the symbol x bar. Okay, so we call that x bar, x with a bar over it. Okay, so let's actually calculate a mean. Before we do that, let's determine or take a look at the formula. So the formula is x bar equals, now this letter here is the Greek letter sigma. Okay. So it's sigma x over n. N is the sample size, so how many numbers you are adding up. And the Greek letter sigma represents summation notation. So the root word of summation is sum meaning to add. So summation notation is a concise way of to represent the sum of the values of a variable. Okay, so basically what we're going to do with the mean is we're going to add up all of the x values and divide by how many there were. Okay, so generally we use x bar because a lot of times we'll call our variable x. If we end up calling it y, then the sample mean there is y bar. Okay, or you could have a bar if your values were a. Generally though, it's going to be x. So most of the time we'll use x bar. All right, so let's actually calculate a sample mean. So I have a data set here. We have 2, 2, 4, 8, 8, 9, 10, 10, 52. All right, so if we want to calculate x bar, we first need to add up all the values. So that's going to go on the top of our fraction. So I'm going to add up all of these. And then I need to divide by how many values there are, the sample size. So let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so let's go to the calculator to actually do our sum. So 2 plus 2 plus 4 plus 8 plus 9 plus 10 plus 10 plus 52. And it looks like I missed one of my 8s. So my sum there is 105. Okay, so I had to change that because I only had 1 8 there, but so the sum there is 105. Okay, and then I'm going to divide that number by 9. Okay, so we end up with about 1.667. So that's my sample mean of the data set. Okay, so this would be a way of describing the center. Now if we think about 11.667 compared to our data set, and if we're using that to describe the center, one issue is that this 11.667 is above every value except for the 52. Okay, so it has 8 values below it and only 1 value above it. I might say that that's actually not a great way to describe the center. Now the reason that is because this 52 is an outlier. This 52 strongly contributed to that sum of 105. Okay, if we eliminate that 52, this mean is going to go way down. Okay, so when you have an outlier, either a high outlier like this, or if we had a low outlier down here, that's really going to distort your mean. Okay, so a lot of times what we'll say is that the mean is sensitive to outliers. Okay, the mean is really influenced by those high or really low values. Okay, so that's one thing to consider when you're calculating a mean. If you have outliers, you might want to use a different measure of center other than the mean. All right, so we have another type of mean, something called the weighted mean. A weighted mean is a type of mean where some data values contribute more than others. Alright, so the example. Suppose you're interested in determining the average amount of money a typical shopper spent on a trip to a sporting goods store. It is known that men spend $22 on a typical trip to a sports store, and women spend about $28. It's also known that 55% of shoppers at this store are men. Okay, so if we're going to calculate the mean for all shoppers, because men represent 55%, we want this mean to be weighted more than this mean. Okay, because men spend a little bit less but shop more often at the stores, we want this mean to be weighted more than this mean. Alright, so the way we're going to do that, so let's just start by notating our two means. A lot of times what I'll do is I'll use subscripts to denote between the men and women's means. So this is x bar with a subscript of m, so I'll say that as x bar sub m and x bar sub w. So the mean for men was $22, the mean for women was $28. Now to calculate the weighted mean is going to equal each of these individual means multiplied by their weights. So I'm going to take this $22 and I'm going to multiply it by the weight for men. And the weight is 55%, but I want that written as a decimal. So 0.55. So it's 22 times 0.55 plus 28 times 0.45. Okay, so once I add those, that will give me the weighted mean. So let's go ahead and do that. 22 times 0.55 plus 28 times 0.45. Okay, and that ends up giving me 24.7. So this is in terms of money. So I'm going to write that as $24.70. Okay, so if we were just to find the average of these two numbers, so if they were weighted equally, we would end up with $25. But since the men are weighted more, this 22 is weighted more than the 28, we're going to get a number a little bit below 25. So we end up with $24.70. So that is how to calculate a weighted mean. So that has been the tutorial on the mean. Thanks for watching.